Okay, hello, good Saturday morning, everyone. Right, welcome back to our November week 2. Okay, so what are we doing today? Let's continue to our revision. Okay, we did until here last week, I think. Okay, we finished until question 10. Okay, here's the thing, we are progressing a little bit too fast. Okay, so today there is actually not much left because some other classes they only do until like question 6 or 7. We already do until question 10. So there's only one part remaining for today, which is our isotope, which you should have some memory still. Okay, because we just learned, oh wait, was it this one? Oh no, I think it's this one. Yeah. Oh yeah, this is one. Okay, so question 10. So we are progressing slightly fast. So today there's not much left to say. There's only isotope. Okay, so anyway, as I was saying, okay, hello, good morning. So as I was saying, we stopped until question 10. There is not much left to say for today. Okay, not much left to say for today. So I might end the class early, so who knows? Because there's only one part left. Okay, anyway, so what are we talking about today? We are talking about isotope. Okay, so we have finished all the periodic table stuff last week. What is proton, electron, and neutron? What is atom, molecule, and ion? If something is made from atom, it's mostly metal, or it could be inert gas. If something is made from molecule, it is usually non-metal. If something is made from ion, it's usually metal plus non-metal. Okay, and what's your electron arrangement? The 2.8 point something, which group they are at, which period they are at. Okay, how is your periodic table arranged? Uh, your valence electron, how many electrons on the outside, are they a metal or non-metal? Are they reactive or are they non-reactive? Okay, we have already done that. What is proton number? Do you remember? Proton number is our focus because proton number is the IC number of an element. Like I said, proton number 8 is always oxygen. Okay, number 8 is always oxygen. It will always be oxygen. So that's the IC number for oxygen. Oxygen is number 8. All right, so let's look at isotope today. So what is isotope? Isotope basically something with the same proton number. Okay, that means they are the same element, but they have different neutron or nucleon number. Okay, since nucleon is proton plus neutron, if neutron is different, then nucleon is different. Right? If 1 plus 1 equals to 2, 1 plus 2 equals to 3. Okay, same proton number, different neutron number or different nucleon number. Okay, think of it this way, proton is like the boys in your class. Neutron is like the girls in your class. Okay, nucleon number is the total student in your class. So if there is same number of boys but different number of girls, of course the total number of your class is going to be different. All right, so what is isotope? Like for example, your carbon 12 and carbon 14. You remember this, right? We just went through this like 3 months ago. So proton number for carbon is 6. Okay, that means carbon 12 has 6 proton, carbon 14 has 6 proton. They are both 6 proton since they have the same proton number. Okay, same proton number. But what is different is the neutron or the nucleon number. For carbon 12, the neutron is 6. For carbon 14, the neutron is 8. So 6 plus 6 equals to 12. 6 plus 8 equals to 14. So they are somehow same, but different. So think of them like clones. Okay, we know that proton number 6 is always carbon, but there's two carbon here. Okay, there's 2 carbon here. They are clones. Imagine someone, you have another one that looks exactly like you, almost the same as you. There's a little bit difference, but almost the same as you. It's like your clone. Then you guys share the same IC number. All right. So table below shows proton number, electron number, nucleon number, and neutron number. So you have your proton here, your electron here, nucleon here, and neutron here. So nucleon is neutron plus proton. Okay, these two adding together, right? So that's why you have 6 plus 6 equals to 12. Okay, you have 6, 7 equals to 13. So 3 plus what equals to 7? That will be 4. 4 plus what equals to 9? That will be 5. You see, we don't really focus on neutron because neutron doesn't really say anything. Okay, neutron doesn't tell us how reactive something is. Okay, it doesn't tell us where is it at the periodic table. So neutron number is something that we don't really care. Okay, because they don't really have much function, unless when you're talking about nuclear. Okay, when you're talking about nuclear energy, when you're talking about nuclear bomb, when you're talking about nuclear fission. Remember, when I shoot the uranium-235 with a neutron, it will split and produce another 3 neutron. That is when we care about the neutron. The others, we don't really care. And neutron, they don't really function much. The one we focus will be proton, because proton tells us everything. Okay, the 2.1, 2.3, 2.8.3, those, they are all your proton number. So B1, state one particle which is positively charged. Okay, so who's positively charged here? Very easy. Let's look at the proton and electron. So for W, this guy has 3 proton. That means it has 3 plus. It has 4 minus, 4 electron. So W in this case is -1. W is negative because W has 1 electron extra. Okay, 1 electron more than the proton. And then for X, this guy is 4 proton, so 4 plus, 3 electrons, so 3 minus. So this guy is +1. Okay, this guy is +1. So this guy has, 1 proton more than electron. As for Y and Z, they are both the same. So this one is neutral, 0, 0. So who is positively charged? Of course, that's your X. Okay, your X is positively charged. So give your reason for the answer in B1. So why is X positively charged? Because it has more proton than electron. Okay, the proton number is higher than electron number. Okay, number of proton okay, TB other number electron. Okay, or you can say more X has more protons than electrons. Okay, X mempunyai lebih proton daripada elektron. Kan, no problem. Okay. Okay, so C among the particle which are isotope. So who is isotope? Who are clones here? These two. You see, they have the same IC number. They have the same IC number. Everything is the same. But neutron is a bit different. Okay, so neutron is a bit different. So these two, they are isotope. So Y and Z. Okay, Y and Z. So number 2, give your reason for the answer in C1. So how do you know they are isotope? Okay, so according to isotope definition, they have the same proton number, different neutron and neutron number. So same here, we can write the same answer. Okay, they have the same proton number, different neutron or neutron number. Number proton sama, neutron atau neutron sama. Yang berbeza. Sorry. You write this answer a lot. Same proton number, different neutron or neutron number. You write this a lot. Because that's the only thing that matters. Okay, here's the thing. Isotope is not gonna come out like this. It's not gonna ask one whole question in subjective question. I mean possible, but not very frequent. So usually the question of isotope, they will come out like this. Okay, last week we did talk about all these proton and neutron and whatever stuff, right? The one in front. All these they will ask like this. And then at the end, maybe C, D, and then they will put another E question and they will ask about isotope. It will be a sub question. Isotope will be a sub question. It will not be one whole question dedicated to isotope because it's too easy. Okay, if they do so, then your exam is gonna be an easy paper. So usually it doesn't happen. Yeah, so it will be a sub question. All right. So even if it comes out, okay lah, most likely isotope will come out in objective question in ABC because it's really easy. All right, so let's look at question 12. The diagram below shows the structure of an atom element P. So this guy has 3 proton, 4 neutron, and 3 electron. Okay, so 3 proton, 3 electron. This guy is neutral. There's no charge here. So state the proton number of element P. Okay, it's already stated here. So it's 3. Easy. So B, what is the nucleon number for element P? So what is nucleon? Nucleon is the middle, everything, the boy plus the girl. So 3 boys, 4 girls, that will be 7. Okay, nucleon number 7. How many valence electrons are present in the atoms of element P? What is valence electron again? Valence electron is the outermost. So outermost is here. Outermost got how many? Outermost got 1. Okay, this is 2.1. You see? 2.1. 2 on the first shell, 1 on the second shell. So 2.1. Okay, so D, if the element of if the atom of element Q has 3 proton and 5 neutron, what is the relationship between element P and Q? Okay, so this is element P, right? There's another element Q. It says here it has 3 proton and 5 neutron. So what's the relationship between these two? You see, same proton number, different neutron or different neutron number. These two, they are clones. So they are isotopes. Okay, BM isotope is without an E. Okay, so explain why. Same answer lah. You have same proton number. Okay, different neutron. BM write yourself. Okay, nombor proton sama, nombor neutron atau nukleon berbeza. Because it's the same answer over and over again. Okay, so anyway, next one. Let's look at question 13. Table below shows the element PQRS with their respective proton and neutron number. So 15 proton number is here, 15, 11, 11, 6. This is neutron number. So let's add another one, which is a neutron number. A neutron. Because proton plus neutron is neutron. This is the boys number. This is the girls number. So total number is 32. How do you get this number? 32 minus 15. 32 minus 15, you get 17. 24 minus 11, you get 13. 23 minus 11, you get 12. 14 minus 6, you get 8. So which pair is an isotope? So who has the same proton number? Who's the IC number same? So you can see here too. Same IC number. So that's Q and R. Q and R. Explain your answer. So again, same proton number, Neutral neutron. Same answer over and over again. Like I said, because that's the main point of proton. That's the main point of isotope. Okay, easy peasy. Okay, next B. State the use of isotope you mentioned in question A in medicine and field of industry. Okay, if you still remember, okay, let's go into our one of my Form 5 revision. Okay, we were just revising on isotope this week. Okay, so remember what is this? I think you learned this a few months ago, right? So where do we use some isotope? Number one is sodium 24. Sodium 24 is a very good tracer. What does it trace? It traces your blood clot. If you drink sodium 24, your blood is going to be radioactive. When you go into an MRI machine, your blood vessel is going to glow. Okay, it's going to highlight the blood vessel. So if there's one part of the blood vessel that is very bright, you know there's a clot there. So if it happens in the heart, there's a heart attack. If it happens in the brain, there's a stroke. So this is how they detect. They use sodium 24. Okay, it functions like a tracer. So cobalt 60, okay, it produces, I think you learned this in Form 3, right? Cobalt 60 produces gamma ray. Gamma ray is very good in killing cells. Okay, to kill your cancer cell. Or same thing here, to kill your bacteria in food. If you want your food to last for a long time, like some company, they want to export their food to overseas. How do they make, especially fruits and veggies, how do they make them last longer than 1 or 2 weeks? They will shoot it with gamma ray, they will shoot it with cobalt 60, okay, before they export the thing out. Okay, so the thing can last longer. Okay, so next, iodine 131, this is used in your thyroid. Okay, remember this thing is called a thyroid gland. Okay, the butterfly looking thing is a thyroid gland. It will produce something called thyroxine. So if you have a cancer here, they will use iodine 131 to treat this cancer, because iodine 131 will produce radiation and kill all the cancer cells here. So you have to know, phosphorus 32, this is also a tracer, but this is not to trace human, this is to trace plants. Okay, we use this to trace for phosphate fertilizer in plants. How do they absorb phosphate? Okay, same thing, this thing is radioactive. If you give this to a plant, if the whole plant turns radioactive, you know the plant is absorbing phosphate very well. If the plant doesn't show you any radioactive, that means the plant got problem absorbing fertilizer. Something is wrong with the absorption. Okay, so carbon 14 is used to understand photosynthesis, okay, to determine photosynthesis, or you can use it in archaeology to do something called carbon dating. Okay, what is carbon dating? Carbon dating is to look at how old something is, how old an artifact is. Let's say you got a dinosaur bone from the soil, okay, you managed to get one dinosaur bone out. Okay, how do they know the bone is like 500,000 years old, okay, 5 million years old? How do they know? It's by doing something called carbon dating. Okay, so American 241, this is to control the thickness of paper. Okay, why do we control the thickness of paper? Because if the paper is too thick, then you're wasting material. If the paper is too thin, then the quality is not there. So this one, uranium 235, we learned this like 1 or 2 months ago. The one you use it in your power station, your nuclear fission. Remember, you crack uranium 235 into half by shooting neutron to it, and it will release a high amount of energy. Your atom bomb also works the same way. All right, so these few that you need to memorize, you learned this in Form 3 before, but now you don't forget because you're still using it in SPM. Okay, so let's move back to our exercise here. So state the isotope you have mentioned. Okay, so when you see 11, okay, that's not our concern. Let's look at 24 and 23. What's the number we learned about 24 just now? That will be our sodium 24. Okay, sodium 24. So the number here, okay, just now you see iodine 131, cobalt 60, phosphorus 32. The number behind is the nuclear number. Okay, that's why carbon 14, the 14 is the nuclear number. So you see, this is carbon 14. This is carbon 14. When you see the word 14, you know it's carbon 14. This one 32, you know, this is phosphorus 32. 24, you know, this is sodium 24. This one you have to memorize. Okay, you should know the number and you should know what element is that. So what's the use of sodium 24? Okay, in the field of medicine. Okay, in terms of medicine, sodium 24 is used to detect blood clot. Don't write tracer. Tracer is to help you understand. Okay, control memesan controlkan darah. Okay, to see where's the blood clot, any blood clot in your heart. Okay, let's say if you have a heart attack. Okay, guys, heart attack is same but different. If you have a heart attack, another guy has a heart attack, it's different. Why? Because okay, heart attack is due to there's a blood clot in your heart. But where's the blood clot? You have so many blood vessels in your heart. Some heart attack is not as serious as another heart attack. So it depends on where it happens. Okay, is it the left coronary artery or the right coronary artery? You have two arteries, two main arteries in your heart. So which one is it? Okay, because they all have different treatment. Okay, how about industry? Okay, you can also use this in pipe. Okay, this is to detect underground pipe leakage. Okay, to find out where's the leak. So you just put sodium 24 into your underground pipe. If one part of the ground, okay, if you put some detector on the ground, if one part is very radioactive, you know sodium 24 is coming up from underground. You know there's a leakage there. Okay, so detect underground part leakage untuk memesan kebocoran pipe bawah tanah. Okay, again, like I said, it is a tracer. It traces where's the leakage. Okay, if your underground pipe is 60 kilometers, you can't be digging up all 60 kilometers of pipe to check, okay, which part is leaking. No, why not just use a tracer? This thing will pinpoint exactly tell you where's the leakage. Okay, so that you can just, because this thing is radioactive, you can just use a radioactive detector. Okay, if there's no radioactive from the ground, you know, there's no leakage. Okay, because the leak has come from somewhere. Okay, hang on. Okay, sorry for that. But anyway, let's look at C. State element P and is used in agriculture. So where do you use P? What is 32? So this is a phosphorus 32. Okay, so what is the use? This is to determine the rate of absorption of fertilizer or phosphate fertilizer if you want to use that. So done. Phosphorus is the main ingredient needed by plants. Okay, it's main ingredient. In fact, you have three things: NPK, nitrogen, phosphorus, and potassium. K is potassium. These three are the basic nutrients for plants. Okay, so we use phosphorus as a tracer. See if they are absorbing nutrients well. Okay, if you detect the plant, the whole thing is radioactive because of phosphorus 32, you know that the plant is absorbing the fertilizer well. Then the problem is somewhere else. Okay, if the plant is not growing well, the problem is somewhere else. But if you detect, okay, you scan the plant, hey, there's no radioactivity. The plant is not radioactive. You know something is wrong with the absorption. The plant is somehow not absorbing the phosphorus. That's why the plant is not growing well. Okay, next D, name element S and state is used in agriculture and archaeology. So what is S? S is carbon 14. Okay, so what's the use in agriculture? What's the use in agriculture? This is to determine the rate of photosynthesis. Same thing is like a tracer. Untuk menentukan other photosynthesis. And in archaeology, this is to determine age of fossil. Here fossil. Or you just want to say carbon dating can lah. I don't know what's carbon dating called in PM. Tarikan carbon, I guess. But if you cannot write that, then fine. Just say determine the age of fossil. How do they determine the mummies? Okay, in ancient Egypt, how old is the mummy? Okay, how what which pharaoh is it? Okay, to basically study history. Yeah. Okay, because here's the thing, ancient Egypt history is lost in translation. Okay, even if you can find some slab that says some Egyptian ancient language, nobody can translate it anymore because the translation is lost. So whatever they found, they cannot understand. So what they do is they will just, if they find a new pharaoh, they find a new pyramid. Okay, so they will use that to do carbon dating and sort of guess what happens last time. Okay, because that's like 5, 6, 7,000 years ago. It's a long time. Okay, languages change. Anyway, so let's look at A, question 14. This is like a very good summary for this chapter. So what's the function of your carbon 14? Okay, this is to estimate the age of fossil. So how do they know when is Paleolithic, when is Mesolithic, when is Neolithic, when is Zaman Logam? They use carbon 14. Right, next one, phosphorus 32. I already told you this is to study absorption of fertilizer. Which is this one. Phosphorus here also was answered already. Okay, to study the metabolism of phosphorus. See how well they absorb phosphorus. Okay, next iodine 131. This is to treat thyroid cancer. Okay, and this is the thyroid. This place can grow cancer. Okay, this place can grow cancer, but it's very rare. Unless you feel something hard here. If there's a lump here, then that might be cancer. Very rare. This thing is very rare. Mostly it's hereditary. That means if your family has a history of it, then most likely you will have the history of it. You will get this thing too. Yeah, that's why heart disease, even mental disease like depression, anxiety, whatnot, they are most likely inherited in the family. Even dementia, even Alzheimer, you know, it's Alzheimer, right? Then you become forgetful when you're old. The thing is also hereditary. So if your family history has a certain disease, then I'm not saying that you will get it, but just be mindful and just be careful because there's a higher chance of you getting it. Okay, and moving on, let's go to the next one. Phobo 60. This is to use to treat your cancer or to kill bacteria. Okay, so answer is this one. Okay, to destroy bacteria. But this thing doesn't last very long. If you have a bunch of strawberry, you kill all the germs with Phobo 60, this thing will still spoil, but it spoils slower. Good for export. Okay, good for export because you don't want to ruin, you don't want to change the quality of the fruits. That's why most fruits, exported fruits, okay, or imported fruits, they will use Phobo 60. Okay, because radiation doesn't really change the quality of the fruit. You just zap it with Phobo 60, all the bacteria is dead, and then they can last maybe 1 or 2 weeks longer. Okay, it doesn't last for a very long time, but at least you can still get it fresh from the shelf. Okay, next one, uranium 235. This is used in your electric, okay, your generator, like the power station. So uranium 235 is very rare, guys. This thing is not available in Malaysia. So if Malaysia were to go nuclear one day, like I said, you cannot find uranium 235. This thing you have to find it, you have to buy it from some other countries. Then Iran has it. That's why Iran last time they were testing nuclear bombs. They were testing missiles because they found uranium 235. Okay, next one. Americium 241. This is to measure the thickness of paper. I already mentioned this to you. So this page is like a summary for you already. Okay, it's like a summary for you. Did they miss anything? Oh, they missed sodium 24. Okay, you can add one more there. Sodium 24 is to detect blood clot or to detect pipe leakage. Okay, sorry for that. All right, so moving on, let's go to question B. So the diagram below shows the activities that involve radio. Okay, what is radioisotope? Okay, all those things we have learned is radioisotope lah. Okay, why do we call it radioisotope instead of isotope? Okay, you see, carbon, you have carbon 12, carbon 13, and carbon 14. Okay, these two, they are isotope, but 14 is a radioisotope. What do we call it? Radioisotope, because it is radioactive. Okay, not all isotopes are radioactive, but those that are radioactive, we call it radioisotope. So somehow these are all radioisotope. They are all radioactive. Okay, that means they could be dangerous to humans. Okay, they can be dangerous to humans. That means if you use sodium 24, okay, if you drink sodium 24 to detect blood clot, it's somehow gonna hurt your body a little bit because it is radioactive. But don't worry, this thing has very short half-life. Okay, what is the half-life? It will eliminate from your body very quickly. You learn this in Form 3, the meaning of half-life. That means time taken for something to drop into half. Okay, that means if you eat 5 grams of radioactive stuff, if it drops into 2.5, the time for it to drop to half, that's what we call a half-life. Okay, okay, so next, let's go to P and Q. So state the radioisotope substance used in P and Q. So what is this? This is a radiotherapy. What is radiotherapy? If you've got cancer, you want to kill your cancer cell, that's what we call radiotherapy. I'm sure you heard of this, right? When someone got cancer, they need to go for 2 treatments, which is radiotherapy. They will use gamma ray to kill the tumor. Second is chemotherapy. Chemotherapy is they give you some kind of chemical, drip it into your body, into your blood, so that they can use the chemical to kill your cancer cell. Okay, both of these methods, they will stop mitosis in your body. Okay, because you know what is mitosis, right? Mitosis is the growth of cell. So cancer cell, they will keep doing mitosis. What we want to stop the mitosis so that cancer cell doesn't grow. Okay, we can stop the growing. So this mitosis is stopped. So not only it stops your cancer cell mitosis, it will also stop your healthy cell mitosis. For example, your hair. For example, your epithelial cell in your digestive system. This is why people, when they do chemotherapy and radiotherapy, they will drop their hair. Cancer patients will drop their hair and they will puke, they will vomit because they are losing all the healthy cells away. Okay, not a very good treatment, but okay, this is a sacrifice that you have to make. This is the only way to treat cancer. Okay, I think I mentioned this in my modern medicine chapter. Radiotherapy and chemotherapy is the only method to treat cancer. Please don't believe in some stupid homeopathy or some herb therapy. It's not going to work. Okay, I say this, I will say this again. Chemotherapy and radiotherapy is the only method that works in curing cancer. Okay, none other methods work. If they tell you some other method is miracle against cancer, they are bullshitting you. Okay, I know a bullshit when I see one. Okay, so don't believe in that. Get your proper treatment. So P, what is the one used? So that will be your cobalt 60. Okay, cobalt 60. And then Q, this is your carbon 14. This artifact one. This is your fossil one. Okay, so carbon 14. So number 2, state the effect of nuclear explosion on humans. This question here. This is your chapter 11. Okay, if you still remember nuclear explosion, what will it do? Okay, any answer that makes sense will score here. You will produce dangerous radiation. Okay, menghasilkan sinaran berbahaya. Okay, or radiasi berbahaya lah, same thing. What else you can say? You can say it causes cancer. Okay, or you can even say it causes deformities. Okay, this is for kecacatan. Okay, because radiation will change your DNA, so it either makes babies deform, or it will cause cancer. So it will cause mutation. Remember that? What is mutation? Mutation is the change in your cell. So this thing will cause mutation. Okay, so number 3, what is the material used to make containers for keeping radioactive substance safely? How do you keep radioactive substance safe? How do you stop radiation? Do you still remember this? You have 3 types of radiation. You have alpha, you have beta, and you have gamma. Okay, yes, good. Okay, you still remember. So to stop alpha, you need paper. To stop beta, you need aluminum. To stop gamma, you need lead. Okay, so to protect from everything, you would use lead. Okay, plumbum in the end. I mean, you can also use concrete lah, but you need a thick concrete. Here's the thing, lead is poisonous. Okay, not your pencil lead, guys. Although this is called pencil lead, it is not lead. This is carbon. This is graphite. Okay, now remember what's graphite? The thing you put into your radioactive, into your nuclear reactor. This is carbon, not lead. Lead is a poisonous metal. It is a heavy metal. Okay, don't you find it funny? To stop something bad, we use something else bad. Okay, to stop radiation, we use another dangerous stuff to stop radiation, which is lead. So the best is by not using anything. Don't expose yourself to radiation. That's the best. Okay, because you need to use another dangerous metal to counter that thing. All right, so C, this is a nuclear power plant, a nuclear power station. If you still remember this thing, you learned this in chapter 11. The uranium-235 inside here. What is this 3 stick here? This 3 stick can be graphite, okay, or it can be boron. What's the function? Okay, let's do a revision also. This is to slow down, okay, or to absorb your neutron. What's the function of the neutron? Do you remember? Neutron is to bombard a uranium-235 so that they can split, and then they will produce 3 neutrons. This 3 neutron will go and bombard another 9. 9 becomes 27. 27 becomes 81. So the more and more you bombard, the more and more they split. So this thing will create something what we call a chain reaction. Okay, tindak balas berantai. If this chain reaction is uncontrolled, you are creating a bomb. You are creating unlimited amount of energy, which is good in a bomb. Because when you are making a bomb, you are trying to kill as many people as you can. Of course, you want uncontrolled chain reaction. But when we are doing it in a power station, we are doing it in a controlled manner. We want this thing to be released in a slow and steady manner. So that's why you put these 3 sticks inside to kind of slow it down or to absorb it so that this thing can be controlled. Okay, we learned this in chapter 11. So name the radioisotope used. You are using uranium-235. Okay, uranium-235. So state the energy generated from the generator. What is the energy here? Okay, this is unrelated to this chapter. This is nuclear energy. Okay, another nuclear. So what is it changing to? This nuclear energy is going to create heat energy, another Haber, which is here. It is used to heat water. Water changes into steam. Steam moves very fast. Steam will spin this thing. What is this thing called? This is a turbine. Okay, turbine. So when it spins the turbine, this is called kinetic energy. Okay, when the turbine spins, when it spins this generator, this thing will turn into electrical energy. Then you have your electricity. Okay, so basically all power stations they work the same way. Okay, it's by heating water. You can use nuclear to heat water, you can heat fossil fuel, you can heat biomass, you can heat natural gas, you can heat coal. The point here is to heat water so that they can become steam and spin the turbine and you will get electricity. All right, so I think that's it. There's no more question, right? Yeah, there's no more question. Okay, so next week we will go into alloy. Okay, chemicals industry, we'll go into alloy. If you still remember what your alloy is, okay, I'll roughly talk about alloy because next week we'll jump straight into the question. Okay, alloys, they are mixture of two metals. Okay, when you have pure metal, they are arranged in a nice uniform pattern. They will slide over. Okay, remember Mangalongso. That makes pure metal very soft. Okay, very soft. Not only they are soft, they are not shiny, they are not resistant to corrosion. Very easily they will oxidize, which is not a good thing. But when you put two atoms together, you put two metals together, this one will turn into this shape. You see, now it's blocking already. All these different sizes blocking, so this thing cannot slide. Okay, alloy, when they cannot slide, they become harder. They become more resistant to corrosion. They become tougher, more suitable to use. Okay, so what's the example of what are the examples of alloy you use? Okay, we use steel. Remember what is steel? When you mix a little bit of carbon into iron, you get something called steel. We call it carbon steel. Okay, they are hard and strong. They are a bit more resistant to corrosion. Steel will still rust. They will still rust, but it rusts at a much slower rate compared to pure iron. Iron will just rust very quickly. Okay, so you know what's a pewter? You use your BG in it. You know the BG right? You use a tin in it. Okay, what is a bronze? Bronze and brass, they're basically cousins because they use copper, but the additive they add is different. Okay, bronze they use tin, your timah, timah, and then this one they will use zinc. So the color is also different. Bronze is copper color, basically reddish brown color. Brass is yellow. Okay, your trumpet, okay, your musical instrument is made from brass. Okay, they are yellow. And then your duralumin, aluminum is aluminium. You use this in your to make aircraft, okay, to make planes. Basically, if you want something lightweight, you will use duralumin. Okay, so that's your alloy. Okay, you need to know alloy is harder. Okay, harder, they are more resistant to corrosion. Since they are more resistant to corrosion, it makes them more attractive. Okay, it makes them appear more beautiful. Okay, that's why you use something called stainless steel. Stainless steel is very shiny. Okay, so we shall go into this next week lah. Okay, so you have your iron nail and your steel nail. Of course, iron will rust first. Okay, steel will rust slower. Okay, I'll go to this next week. All right, so I think that's it for today. Okay, because we have to wait for the other class to catch up. So I think I'm going to stop here. Okay, we actually did a lot of all the difficult stuff last week already. It's a good thing lah. Okay, because this year I believe this week you started your school, right? So that's why many people are very tired this week. So glad that we did the hard stuff last week. Okay, so the one we learned last week, those are the important ones. Go and revise more. What's the proton number? What does proton number mean? Okay, what's the electron arrangement? Okay, how do you determine which group and which period they are? Very, very important. Okay, so I think I'm going to stop here. So that's it for this week. Thank you for coming. Okay, hope you have a happy weekend. I will see you again next week. All right, so happy Saturday. See you next week and bye-bye.